Hey all, so we're going to start today by defining polygons, but the main focus of today's lesson is talking about the interior and exterior angles of polygons and figuring out what they sum to. So first of all, what is a polygon? It's a closed shape with straight edges. So this is a really umbrella term. Almost every shape that we learn about in geometry is a polygon. We'll learn about circles eventually. They're not polygons because they don't have straight edges, but pretty much every other shape is a polygon. All right, so this is like an umbrella term that describes most of the things that we'll learn about. Here is a diagram of some polygons. And then certain polygons have special names that you need to have memorized. Some of these you'll already know. Obviously, if it has three sides, it's a triangle. If it has four sides, it's a quadrilateral. If you didn't already know that, that one's easy to remember because you probably know a lot of words that have quad in it that make you think of four, like quadruplets, four babies. Sometimes they call an ATV with four wheels a quad. Pentagon might be a new word. That's five sides. Hexagon, like a stop sign, that's six. Heptagon, I feel like I have to relearn that word every year. That's seven sides. Octagon, you're probably familiar with because octopuses have eight legs, so octagons have eight sides. Nonagon is nine. You can remember that because they both begin with N, I guess. 10 is decagon, and 12 is dodecagon. You might be wondering why this list skips 11 and why it doesn't keep going. I actually don't know why, but those polygons we call them just 11 gons, or if it had 65 sides, 65 gone. All right, so it's only these polygons that get like special names. Any other polygon, you just say whatever the side length is, and then whatever, excuse me, however many sides it has, and then the word gone. This is a review from earlier in the year, interior and exterior angles. Interior should make you think of inside. So we have a pentagon here, and we can see that there are five angles on the inside. Those are all interior angles. And then if you extend the sides of the polygon, like I've done in this diagram, you create exterior angles. So exterior angles, they're on the outside. They're pictured in blue in this diagram. And you can see the relationship between exterior and interior angles. Um, they form a linear pair. So exterior angles always form a linear pair with interior angles. That means that they're supplementary. That means they add up to 180. Whoa, whoa. Okay, so this chart is a little bit overwhelming at first, and you might be even more overwhelmed to hear that you are responsible for knowing everything on this chart. So you might be like, what the heck? I'm never going to be able to memorize all of this. But we'll talk about patterns and how we can use those patterns to actually know this whole chart really easily. So we've already talked about the names of the polygons. You are responsible for those. Um, like if I just say octagon, you should know that's eight sides. Things that you might notice in these two columns. There are patterns in these two columns. So why don't you take a minute, see if you can notice any patterns and describe them briefly. So the sum of the exterior angles, that's the easiest pattern to recognize. It's always 360. So no matter how many sides your polygon has, if you add up all of the exterior angles, they are guaranteed to add up to 360. So regardless of whether we're talking about a triangle or a polygon with 1,500 sides, the exterior angles all added up are going to equal 360. So that pattern's easy. This one might be a little bit harder to see. With every increase in the number of sides, the sum of the interior angles goes up by 180. So, like I said, you're responsible for knowing everything in this chart, but you don't have to memorize this whole chart. On this slide, we are going to summarize everything that was in the last chart. So this way smaller table is going to summarize everything from the previous slide. So if your number of sides is n, we need to write expressions for the sum of the interior angles and the sum of the exterior angles based on the patterns that we noticed on the previous slide. So the easiest one is the sum of the exterior angles, 360 degrees. I just finished telling you that no matter how many sides a polygon has, the sum of the exterior angles is 360. This is harder to come up with. So I want you to spend a minute thinking about this. So if you all would pause the video and think about it, you don't have to type your answers in because I think it's kind of a tough question. But our goal here is to write an expression that represents the sum of the interior angles of any polygon using that variable n. So just think about that. There it is. So 180 and then in parentheses n minus 2. This expression represents the sum of the interior angles of any polygon. So if we wanted to find the sum of the interior angles of a polygon, we can use this formula and it works no matter how many sides that polygon has. Let me kind of demonstrate how it works. So let's say that I wanted to find the sum of the interior angles of a dodecagon. A dodecagon has 12 sides, so I'm going to plug in 12 for n. Again, n represents the number of sides. So dodecagon, 12 sides, that n became a 12. And then if you wanted to, you could type this whole thing into your calculator as long as you have the parentheses. I think it's easier to simplify and then multiply. So I always just kind of do this math in my head. 12 minus 2 is 10, and then I multiply. So 1,800. So the sum of the interior angles of a dodecagon is 1,800. And if you go back in the video to the chart that I just showed you on the last slide, that's what that chart says. So instead of memorizing all the numbers on the last chart, you can just memorize this kind of formula, 180 n minus 2, because you can use that for any polygon. Let's put this into practice on the next slide. I want you all to think about this on your own. Again, you're going to kind of do the same exact work that I just did on the last slide. So what is the sum of the interior angles of a decagon? And in case you don't remember, a decagon has 10 sides. So take a minute, type your final answer in, the sum of the interior angles of a decagon. So again, we're using this formula. Whenever it's the sum of the interior angles, you're using this formula, 180 n minus 2. If we're talking about a decagon that has 10 sides, so our n would be 10. And then I simplified that to 8, just in my head. And then I took out my calculator and did 180 times 8 and got 1,440 degrees. And it's important to remember that angles are always measured in degrees. So if you could try to remember to include degrees in your final answer, that would be fantastic. In case one was confusing, go ahead and do 2 now. It's really, really similar. So now that you've seen one more example of it, I think that everyone's going to be able to nail 2. So spend another minute, do 2 on your own, type your final answer in. So here's my work. Again, a hexagon is 6 sides, so I plugged in 6 for n. I simplified, and then finally I used my calculator to get 720 degrees. Go ahead and think about 3 and read that question carefully. So if you did any work for 3, you may not have read the question carefully enough. In 1, I'm asking about interior angles. In 2, I'm asking about interior angles. But in 3, I'm asking about the sum of the exterior angles. So I actually didn't need to do any work for this. The sum of the exterior angles of any polygon in the whole world is 360. So even if I had stopped reading after this word angles, even if I hadn't read pentagon, this word didn't matter because no matter what type of polygon it is, the answer was going to be 360. It's always 360 for exterior angles. All right, so these next 2 questions are a good deal harder. They are related to the questions that we just did. Take a minute on your own, think about 4 and think about how you might start it. If you could type like your starting thoughts in, that would be great. Again, you've never seen a question like this, so it's totally okay to write, I don't know, but I want you to give it at least a minute of thought. How would you start this? What would your starting equation be? Or maybe just give me a description of your steps. All right, so I'm looking at this. I can see that it's a hexagon if I count up all the sides. Off the top of my head, I do not know what the interior angles of a hexagon add up to. I'm not wasting any of my brain space memorizing that fact because I can just calculate it with our formula. So 186 minus 2, again, I plugged in 6 because it's a hexagon with 6 sides, is 720. So I know that all 6 of those angles added up are going to give me 720. So now that I know 720, now I can actually write an equation involving x. Here's my equation involving x. I added up all 6 angles. I set it equal to 720. In the past, students have not included this 90. I think just like they don't see the number there, so they don't think it has to be included. It does. We have to add up all of the angles. So even though this isn't labeled with a 90, we do need to include it in our equation. And further, we know it's a right angle because it has this little right angle box. Take a minute to solve this equation. If you would type your final answer in, that would be great. So there's a couple ways to do this. You could either individually subtract all of these numbers from 720, or what I like to do is I add them all up. So I combined all of these numbers to get 573. And then I subtracted that from 720. We're going to get the same answer either way, 147. So you can either subtract them all individually or add them up and then subtract them. Now that I've kind of modeled this question once, why don't you see if you can do 5 entirely on your own? If you would type in your final answer, that would be great. If you feel like you didn't get your final answer correct, at least type in something. Your starting equation, a thought that might be helpful, a question. Just a note, this pentagon, not drawn to scale. So you're going to get an angle measure that doesn't totally look right. So again, my first step, off the top of my head, I do not know what the interior angles of a pentagon add up to. So I have to use my formula to calculate that. So I plugged in 5. And then I just plug this into my calculator. I think what I actually did on my calculator is 180 times 3, because I kind of just automatically simplified that in my head. Either way, you get 540. So all 5 of these angles add up to 540. That leads me to my starting equation. I'm going to solve this the exact same way that I did in 4. I'm going to combine all these like terms on the same side by adding, and then I'm going to subtract in my last step for a final answer of 163. So this angle, if I had to guess, it kind of looks like, I don't know, maybe 100 degrees. So it does seem a little bit weird that it's 163. Like I said, not drawn to scale. All right, last question of today's lesson. I want you to start by either typing in a starting equation or typing in something that you notice that's different about this problem compared to the other problems. So this problem, unlike the other two that you just did, is all about exterior angles. So I actually think this problem is less work than the last one because we automatically know what all of the angles add up to. It's always 360. So we don't have to use the formula 180 n minus 2. We can just go right into this equation because we know that they all add up to, oh my goodness, my equation's wrong. Hold on, let me change that. There we go. Sorry, I had that as 720 earlier. It should be 360. Um, now that we're all on the same page about what the starting equation is, see if y'all can solve for x. The algebra in this one is a tiny bit harder than the algebra in the other ones, but I think that you all can handle it. All right, here's my work. Combined like terms, so x and 3x combined to give us 4x, and 75 plus 80 plus 42 combined to give me 197. And then I subtracted 197, and then I divided by 4. So some of you may have been freaked out that you got a decimal, but decimals are okay. That is my final answer for this one. X equals 40.75. Hopefully this video has made sense. We'll practice more with finding the sum of interior and exterior angles in class.